All right, so exam review,
If
chapter
you are
4.
her friend, go over here.
Chapter 4.
That means you are not her friend, man. That means.
Chapter 4. Periodic properties of the elements.
Teach me every single shit.
So you know who came up with the idea of periodic table?
Nah.
Mendeleev.
Nobody going to give a shit, man, on the exam. They are not going to ask you question about it.
Mendeleev. So you know what he did? He aligned all the elements according to atomic mass. So the mass of the atoms, I think the elements. So he first he just drew it on a straight line, and then just, named all the elements like hydrogen, helium, lithium, and then
Beryllium, boron, carbon,
Yeah,
nitrogen, oxygen,
exactly.
fluorine,
And then he
sodium,
found-
magnesium, aluminum, calcium, sodium, magnesium, fluorine, calcium,
Okay.
titanium, scandium, vanadium.
I swear to God. And then he found a regular pattern, right? And then that's how they randomly came up with the periodic table. But then there were some errors in that. So apparently the modern table now is listing elements according to the atomic number rather than the atomic mass.
You're
So-
fucking man.
So
I'm
modern
making movie, man. Fuck.
modern table is now arranged by atomic number rather than atomic mass. And then chapter 4 we talk about electron configuration. Do you know how to do that?
Come on, man. Come
So,
on, man.
Hydrogen, you
Come
know,
on, you can do it, man.
there's like one electron, so
1x1.
one, like that, right? Oh, S.
One
One.
in front.
One.
That's, yeah, coefficient is important.
Yes, coefficients is important. Don't forget that. So basically, what is this, Happy? Like, what is this?
The
straight
positive
line?
electron, like spin.
Spin rate. So tell them
Yes.
how many spin rates there are.
There are two, like
There's two.
plus 1/2, comma, subtract negative 1/2.
So there's plus 1/2 and minus 1/2.
Yeah.
Okay, cool.
And they cannot like in a particular orbit, they cannot be like plus 1/2 for both of them. It has to be like plus 1/2, and the second one has to be negative 1/2.
Yeah. So
because the electrons are has to be oppositely attracted towards each.
yeah. So that's called the Pauli exclusion principle. So
yeah.
Pauli exclusion principle. Pauli
Yeah, they
exclusion.
don't have like the same. You don't get you don't have like. You don't have like a same quantum number, like same 4 quantum numbers.
Exactly. Yeah. We're not. So it says that no two electron in an atom can have the same four quantum numbers. So because they have 4 quantum numbers, which are N, L, ML, and MP, right?
M sub S.
MS. Yeah. So any electrons, they can't have all of these 4 things have like the same thing. So they should be different. Let's see. And then we also talk about Coulomb's law, shielding, and penetration.
I'm just like wondering, like you eat like too much, man. Like how you guys get like skinny, man?
What?
Like how you guys get skinny? Like you guys eat too much of that as compared to me.
Yeah, you eat like just 2 pizza, right?
See, and you eat like done, right?
Yeah.
But still you are like
No.
skinny
You
and
should
I'm,
come. You
like,
should come swimming with me then.
How
Swimming,
like,
it like I think works on your. It's like the entire body exercise. So when you do like weights, you just train your like a particular muscle. But swimming or running,
Is affect the entire body.
Entire body.
if, I mean, come on, maybe.
So if you want to lose weight, you want to run
I'll
rather
see.
than doing weights.
Do
Although
they have
doing
like
weights,
swimsuits there?
no, they don't.
I have to buy it.
Yes. Or you can run. There's a running machine.
Yeah,
T-Rex.
I'll join you.
Okay.
I'll join.
Okay, so we
someday.
talked about Coulomb's law.
Ooh.
Oh, yeah. So what is a Coulomb law, Happy?
It just basically tells you the force between 2 electrons, and also like if they have like opposite charge, it just tells you like the force between those opposite charges, and it also tells you the distance between 2 nuclei.
Yeah. So what I learned is
It's
like,
kind of like F equals to K Q1 multiplied by Q2 over T.
Yeah, so, well, the equation that I wrote was a little quite similar but different, although the ratio is the same.
What? Yeah, this one.
Yeah.
This one is
Yeah,
different.
that's right. So this E0, this is a constant. This is 8.85 times 10 to the negative 12. I don't know what that is, but that's that.
And also, like, if f equals to 0, that means you have like
What's F?
force.
Oh, force. Okay.
So I'm talking about, you know what formula I'm talking about? I'm talking about like f equals to k d1 sub qt over t. So it's kind of like if f gets equals to 0, that means we have like electron attraction, and if f is gonna be greater than 0, that means we are having like electron repulsion.
Yeah. Okay, so what I learned is,
And this is like positive charge, this is negative charge, and this is the distance between two nuclei. This is the distance between two nuclei. This.
yeah. Okay. So, oh, you don't have to write it that. So what you're saying is that the R is the distance between two.
Yeah, you can say that.
Like that.
Two nuclei.
Yeah. So that's the R.
Yeah.
Okay, cool. Yeah, so it also says the potential energy. Well, that's what they refer to the E right here.
Oh, so that's
Yeah.
potential energy.
Yeah, that's the potential.
So you
energy.
get that from the book.
Yeah, from the book. So it says.
Because our teacher, like, she taught us different. She used that one.
Oh really?
Force equals to that
Okay.
for Coulomb.
I don't know. Maybe my teacher used that too, but I don't know. So it says when we have the same charges, for example, we have positive here and positive here, it obviously repels, right?
Yeah.
So this repel would have a positive energy. So this would be positive. Or it could be same, like it has to be same. It could be negative, negative.
But if,
and
if it's going to be
repulses-
negative and negative, that's still repulsive.
Yeah, that's still positive energy. Because if you look at the equation, it's
They-
positive, positive, or negative, negative. It's both positive.
No, it has to be positive and negative.
No, it said it can be both.
Positive. Okay.
Yeah. But if it's positive, negative, or
that's
negative,
that's the
positive,
direction. These are like the directions when
Yeah.
the electron attract, and these are like repulsion when the electron like just go away from each other.
yeah, that's repulsion. That's
And also you can say like E equals to 0 at this point. E equals to 0,
Okay.
and for this one E equals to 0, and for that one E equals to greater than 0.
Okay. Yeah. So that's basically it for the. So yeah, just memorize that equation or the one
But
that I
that,
wrote.
what both of them are same.
Yeah.
right?
So F
both of them are same.
equals K Q1
Q2 over D.
over D.
D is the distance.
So R or D.
Yes. R/D.
Okay, cool.
Oh yeah, cool man.
Cool, man.
Cool, my Korean man. Come on, man.
We gotta go over chapter 4 really fast.
I'm getting hungry, man. Why?
Hungry? We can go get some McDonald's.
See
Alright,
my
and then we
face,
can talk
my
about
fucking
shielding.
face. See my fucking face.
Shielding.
Shielding.
So it says repulsion of one electron by other electrons is screening or shielding, which means that, let's see, I'm gonna draw lithium
And we can also like
plus. I'm gonna draw lithium plus. So it's gonna be plus 3 plus, and then like 1 minus here, 1 minus here, right? Because this has.
good job, bad job, good job.
But when it's trying to interact with a random electron right there, this experiences shielding. Like it can't really go through this because if it goes through it, that's called penetration.
Yeah,
But it
it
can't.
cannot
This is
go-
like the shielding. This
Yeah, it
dotted
cannot
line
go
is the
like-
shielding.
directly towards the nucleus because they are doing repulsion.
Exactly,
Which
yeah.
like blocking, which is like kind of like inhibit that electron to attract towards the
Yeah,
nucleus.
exactly.
So they are I think they are like for this one they are like weaker effective nuclear charge towards
Mhm.
this.
So it does talk about effective nuclear charge. Actually, net charge of. So this receives a net charge of +1. So
Yeah,
how that
yeah.
works is we have 3 plus here.
Yeah,
And
you
then-
know why? Because of ionization energy.
Yeah, and also there's 2 electrons, so like -2. That's like 1. So
That's the
yeah.
effective nuclear charge.
Net charge.
That's ZF.
Which is also known as ZEF.
Z sub F. Z sub E F.
Yeah, ZEF. Is equal
Strange.
to 1 plus. So yeah, this
You don't have to
has
you
1
don't
plus.
necessarily have to put plus. It's
Okay.
just only one. You know.
Yeah, that's it. Cool.
Next topic.
Next topic. We can talk about
Teach me fucking every single.
penetration.
Every single